everyone. We're going to keep going on Chapter 7 today. If you recall, last class was a little bit short. That's because I just want to do the first half of Chapter 7, and the second half is very, very short. So we're going to finish up Chapter 7, and then I'm going to do Chapter 8 really quickly lumped in today's class because it's kind of basically just an extension of the previous chapter. So this is, to start with, Chapter 7, Part 2. And if you'll recall last class, we were talking about consumer surplus. So the idea is that we could take this supply-demand graph that we've just been using over and over again, and in the supply and demand, we can plot a particular area, and that area will tell us the amount of surplus that consumers get when they participate in the market. So the idea is basically we're going to take this one graph in this whole class, draw it a million times, and this is kind of like the hammer and the screwdriver. It's like the one tool that you can just like use over and over again to build a whole bunch of different things. So we're going to use this tool to build something, and what we're going to build here is consumer surplus. So the idea was if we have this graph, we can find the area of the triangle that exists above the price that is in the market and below the demand, and this triangle has an area that's equal to consumer surplus. Okay, today we're going to do producer surplus. It's very, very similar in terms of intuition, so I'm going to kind of show you first what it looks like, and then I'm going to explain it to you. So basically today we're going to be thinking about if this is how much surplus consumers get from participating in a market, then how much surplus or goodness do producers get out of participating? So instead of using the demand curve to be kind of our anchor for the triangle, what we're going to see today is that the producer surplus is going to also be equal to the area of a triangle, but now we're going to look at the triangle that exists above the supply curve and below the price. And this triangle has an area, and the area of that triangle is equal to producer surplus. Okay, so why is that producer surplus? Okay, the idea is that the supply curve in a market represents suppliers or sellers' willingness to sell. So let's write this out. So the supply curve represents sellers or producers' willingness, and this is important, willingness to sell. So when we're thinking about consumer surplus, we said consumer surplus is very related to willingness to buy. So the example I gave you was my willingness to pay for a cup of coffee at different times of the day. And so that's kind of led to a demand for coffee, which was based on my willingness to buy. Now the supply curve is going to be related to a seller's willingness to sell. So let me give you kind of a concrete example. So let's think about let's think about kind of somebody's willingness to take an hour out of their day and bake cookies so that they can go and sell those cookies. So the example we're going to be thinking about is willingness to take an hour out of your day. And then you also have to buy ingredients. Buy ingredients. Bake a dozen cookies. And sell them. So this is, overall, it's like your willingness to sell, given that selling entails time and money for the ingredients and just overall effort that is costly. Okay, let's think about different people who have different willingnesses to sell. So I'm going to give you 3 people that you know who differ in terms of time constraints. So we're going to have a table here that has a person, and then I'm going to have the second column be price, but this is kind of like the price at which you're willing to take all the work of buying a dozen cookies, or it would be the price at which you would require this price for your cookies if you're going to like go to all the effort of buying the cookies. So the first person you can think about is me. My initials are LW, Lindsay Woodworth. And let's suppose, like, for me, if I am going to, like, take an hour out of my day to, like, buy ingredients for cookies and make cookies, then in order for me to be willing to bake and sell a dozen cookies, I would need to get maybe $10 back. Like, I would need to sell the cookies for $10 in order for it to be worth it for me to actually bake and sell the cookies. Okay, Bob Caslin, BC, is a little bit busier than I am. So let's just hypothetically think, like, how much would he need to get for a dozen cookies in order for him to be willing to take an hour out of his day to, like, bake cookies and, like, sell them? Well, he's a lot busier than I am, so he's probably going to, like, you're going to have to pay him quite a bit to do this. So maybe the price at which he would be willing to sell is $50 per dozen. So in other words, this would be like him saying, well, if you'll give me $50 to do it, then I'll take an hour of my day, like buy the ingredients, bake some cookies for you, sell you a dozen cookies, but you have to give me in exchange $50. So that's the price at which he's willing to sell. Someone who's even busier is the President of the United States. So we've got DT, Donald Trump, who's also like super rich. And so he's rich and he's busy. So like it's really not worth it for him to like go to the store, buy ingredients, take 1 hour off, and like buy cookies. And furthermore, he doesn't really need money. So maybe for him to be willing to actually bake cookies, you have to give him like $1,000 per dozen. Anything less than that, like it's not worth it for him to like take an hour out of his day to bake cookies. Okay, what we can do with this is we can kind of deduce what a supply curve might look like. So if these are three different people's willingness to sell, then what we might do is we might plot the quantity, where the quantity is like how many dozens of cookies are sold on the market, against the selling price point. Okay, so for example, suppose the price in the market for a dozen cookies was $10. Well, if that was the price for each dozen cookies, then how many cookies would be sold? Well, I would be willing to take an hour of my day and supply a dozen cookies. So we got 1 dozen contributed by me. Bob Caslin isn't going to like contribute or sell any cookies because he needs at least $50 to contribute a dozen. Similarly, Donald Trump needs at least $1,000. He's not going to sell or contribute any. So at a price of $10, there is going to be 1 dozen cookies that are sold. Those 1 dozen cookies are going to be offered by me, LW. So we're going to have 1 coordinate here. If the market price is instead $50, then how many cookies would be sold? Well, I would definitely be willing to take an hour of my day and like make cookies and sell them if I was going to get $50 for them. So like 1 dozen would be offered by me. Bob Caslin would say $50. Like, okay, I'll go ahead and do it. So he would also contribute 1 dozen cookies at a price of $50. So we would have total in the market 2 dozen cookies that are offered for sale. 1 dozen would come from me. Another dozen would come from Bob Caslin. Okay, so that means we have another coordinate here. Okay, this is not drawn to scale, but suppose we had a price point up here at $1,000. How many cookies would be offered for sale? I'm definitely going to contribute a dozen. Like, I'm comfortable taking $10 for a dozen cookies. If you give me 1,000, like, I'll go ahead and make the dozen. Similarly, Bob Caslin, he'll go ahead and make the dozen. So we got 2 dozen cookies so far. Donald Trump, he says, if you pay me $1,000, like, I'll go ahead and take an hour out of my day and make cookies. So now we got 3 people. Each person's chipping in a dozen cookies in the market. So we're going to have a quantity of 3 dozen. 1 dozen's coming from me. 1 dozen's coming from Bob Caslin. 1 dozen is coming from Donald Trump. But at this quantity, we're up here at a price of $1,000. So this is kind of like a micro version of a little chunk of the supply curve. But the idea is you can kind of do this for an entire market, and you could trace out a supply curve. Okay, the reason this is important is because, again, we're trying to figure out why this is producer surplus. So if this is basically a supply curve, then let's think about what would happen in the market if the going price for each one dozen cookies was $15. Let's just say price equals 15. And let's just say this is the price in the market. Well, at a price of 15, I'm the only person who's willing to sell a cookie. So I'm going to try to sell a dozen. No one else is going to. So at a price of 15, write this out. So at a price equal to 15, I, Lindsay Woodworth, will have a producer surplus of $5. Okay, why will I have a producer surplus of $5? It'll be $5 because I'm happy to sell a dozen cookies for $10, but I'm getting $15 per dozen. So this vertical distance between the supply curve and the price is 5. So at a price of 15, Lindsay Woodworth will have a producer surplus. We'll have a surplus. I am a producer. Surplus of $5. Okay, what if instead of $15, what if the market price was like $60? Let's have price equals to 60. And we'd have another price up here. Well, this is great for me because I'm comfortable with $10. So my surplus is my individual producer surplus would rise a lot. So I would be comfortable with $10. I'm getting $60. So my consumer producer surplus here would be $50. So start writing this out. So at a price of 60, Lindsay Woodworth will have a producer surplus of $50. And on top of that, Bob Caslin is now willing to bake cookies. He would be willing to take $50 to make a dozen, but he's getting $60. So he's going to have a producer surplus of $10. So, and Bob Caslin will have a producer surplus of $10. So overall, the total producer surplus is equal to my 50 plus USC presidents of 10 of 60. Okay, let's just think about this graphically. So for me, again, I'm comfortable with 10. I'm getting 60. So the difference between 60 and 10 is 50. That's the vertical distance of this little leg that I've drawn. For Bob Caslin, he's comfortable with 50. He's getting 60. So the difference between that is 10. That's equivalent to this little leg that I've drawn. And basically, again, this is like a zoomed in version of this. If you just kind of do this over and over and over and over again, which if you're into math is kind of like taking the integral of something, you're figuring out the area, then what you're going to get is a whole bunch of little legs. You connect all the little legs, and eventually you're going to get the area of a triangle where everything is bounded in the top part by the price, and the bottom part is the supply curve. Okay, so let me write out a couple things so you make sure to have it in your notes. So technically, let's just kind of think about how do we define producer surplus. So this is going to be like official definition. So the definition of producer surplus. So definition of producer surplus is going to be equal to, I'm just going to write this math terms, the price minus seller's willingness to sell. And again, recall that this willingness to sell is effectively the supply curve. The supply curve is determined based on people's willingness to sell. Willingness to sell, not her. Okay, graphically, this is the triangle. The triangle, which is equivalent to the area underneath the price that is currently in the market and above the supply curve. So graphically, this is equal to, put that, the area below the price and above the supply curve. And note that it's always going to be a triangle. And note that the area of a triangle is 1/2 base times height. This is just kind of FYI in case you forgot that. I'm going to spoon feed you a little bit here. So how, if I gave you equations or a picture of supply and demand, would you figure out the area? Well, 1/2 would be multiplied by the base of the triangle. The base of the triangle is going to be the quantity of items that are exchanged in the market. The height of the triangle is going to be equal to the price minus the supply curve's intercept along the vertical axis. So when you're actually calculating this, you'll have a number for this this intercept. But basically, you would take the difference between the price and the intercept. That would be the height of the triangle. You multiply that by the quantity, which is the base, multiplied by 1/2, and that will give you the area of the triangle. Okay, so this brings us to the next thing, which is very intuitive, and that is total surplus. Okay, total surplus is exactly what it sounds like. It's the total surplus. So we have two types of surpluses so far. We have consumer surplus, which we talked about last class, and now we have producer surplus. You put it together and you have total surplus. So total surplus, we're going to call this TS, is equal to consumer surplus plus producer surplus. So in the graph, what we've got here is we have our supply, our demand. There's going to be some equilibrium price in the market. Well, we know that everything above the price below demand is consumer surplus. We know everything that's below the price above the supply curve is producer surplus. And now we know that the total surplus is just the summation of consumer surplus plus producer surplus. So if we take the area of this entire triangle, that entire triangle is going to have an area that's equal to the total surplus. So again, this is hopefully very intuitive. Okay, so how do we conceptually think about total surplus? So total surplus is effectively kind of like the well-being of everybody in society. So it's kind of like we take the people who are buying in the market, we figure out how much goodness they get out of participating in this market. We do the same thing for the other side of the market. So now we've got both the suppliers and the demanders. We add up kind of the goodness or the well-being that everybody realizes, and then that gives us the total well-being in the market. So for your notes, you can just say, we think of this as economic well-being of everyone in society. Okay, so this begs an important question. So if this area, the entire triangle, kind of represents the well-being of everybody, then what an economist might want is to figure out how do we maximize the area of this triangle? Or in other words, how do we make everyone's economic well-being as big as it possibly could be? So, we're going to kind of think about this a little bit. So again, the idea is we want, most of the time, most people want economic well-being or total surplus to be maximized. So how might we do that? So we'll frame this as a question. So the question is, how do we maximize total surplus? Okay, I'm going to give you the answer, then I'm going to show you why the answer is the way it is. So the answer is we, and I'm going to put this in quotes, leave the market alone so that it reaches the equilibrium. And this is because the equilibrium price and quantity make the total surplus triangle as big as it can be. Okay, so let me kind of prove this by contradiction. So let's think about the equilibrium. So this is what the market would look like. So I'm going to do 3 side-by-side pictures, so you might leave room for this on your own paper. So let's think about what the market would look like if we didn't touch it. And we're going to consider the same market. So I'm going to try to draw these curves so that they're exactly the same and comparisons will actually be valid. Close-ish. Okay, so case 1 is, let's consider what total surplus would be if we left the market alone. Okay, if we left the market alone, then this would be the equilibrium price that emerges. Again, we would get the top triangle for consumer surplus. We would get the bottom triangle for producer surplus. If we left the market alone, then this entire triangle would be realized as total surplus, nothing new. Okay, what if we raised the price above the equilibrium price? What would happen? Well, if we raised the market price above the equilibrium price and say we somehow intervened in the market, or the government did, and they made the price up there. Okay, think about what we know about surpluses and shortages. If this is the market price, and this is demand and supply, well, this market price, this is how many units consumers demand. So this is the quantity demanded. This is how many units are supplied. So really in the market, this is the number of units that are exchanged, because although this many units are sitting on the shelf, these are the number of units that are purchased. So this is the salient quantity in the market. Like, these are the number of goods that are actually exchanged between the buyers and the sellers. Okay, that means that what we have now is a price up here, a quantity down here. So in this market, consumer surplus is pretty easy to figure out. So consumer surplus is the area that is underneath the demand curve above the price, but the price is now pretty high. So in this market, this little triangle up here is going to be the consumer surplus. And the producer surplus, again, is bounded by the price and the supply curve, but now we've kind of truncated the distance that we go over, because we're only exchanging this many units in the market, not like this higher level. So what we get now is a producer surplus that's equal to the area of this shape. I should know the name of it, but I don't. And so now this whole black shaded region is going to be the total surplus. This black shaded region is smaller than the original black shaded region. So we used to have this little segment in here that was incorporated into the total surplus, which again was like well-being that was realized in the economy. But when the price drifted above the equilibrium, we lost this amount of surplus. So what we call the amount that we lose is deadweight loss. So the idea of deadweight loss is it's the surplus that is not realized because the market is distorted, and so some of the economic well-being that used to exist is no longer there, like it disappears. Okay, what if somehow in the market somebody intervened and we lowered the price below the equilibrium? Well, if we did that, then the price in the market would have to be somewhere down here. And again, this is supply, this is demand. And we can basically do the same thing. So if the price is down here, then at this low price, very few sellers would be willing to sell their product at that lower price. So this would be the quantity that is sold at a cheap price. Lots of people want to buy it, so this is the quantity that's demanded. We would have a shortage because the quantity demanded exceeds the quantity supplied. And so since there's like this constraint in the number of units that are supplied, this is the salient number for the number of units that will actually be transacted. So QS will actually be exchanged in the market, and the price is going to be the blue P. Okay, so let's think about consumer surplus. Consumer surplus is the area that's underneath the demand curve above the price. Well, we've truncated ourselves right here because now this is the new smaller number of units that are exchanged. So what we're going to do is we're going to stop ourselves right there because this is the quantity that we've maxed out at. We're going to take the area that is below the demand curve and above this lower market price. This is going to be the new consumer surplus. For the producer surplus is the area that's underneath the price above the supply curve. So this little triangle down here would be the producer surplus. The whole shaded region is the total surplus in the market. That's the total economic well-being that's realized by everybody. It's smaller than what it originally was when we were sitting at the equilibrium price. And the way we see that is because, or another way we can see it other than just eyeballing it, is that we used to have this little unshaded region that was a part of the total surplus. Now we don't have it anymore, so this is deadweight loss. And so basically the takeaway is, if we want an economy where we kind of maximize well-being, then what do we need to do? We need to let the market kind of shake out so that it reaches the equilibrium. If we come into the market and we try to raise the price or lower the price and deviate from the equilibrium, then what actually happens is we stunt the growth, the economic growth in the market. Okay, so this kind of brings up an important issue, and that is the distinction between efficiency in a market and equity in a market. Okay, so we're going to write efficiency versus equity. Okay, let me descriptively tell you what these things are. Okay, efficiency is basically how healthy is a market in total. So efficiency has to do with like how big is the overall shaded area. So it has to do with like the total surplus. Equity has to do with among the shaded area, how much of the shaded area is going towards consumer surplus versus producer surplus. So the picture we usually think about in economics is a pie, and we say the economic well-being of a country is like a pie. So the bigger the pie is, like the better, right? So if you have a bigger pie, then that relates to efficiency. It's kind of like how much total surplus you have. Equity says we have this pie, but the pie is sliced into two pieces. One piece of it goes to consumers, one piece of it goes to producers. So if the pie is split down the middle and consumers get half of the surplus, producers get half of the surplus, then that's very equitable. But what might be the case is that you would have a huge, huge pie. So like we're doing great in efficiency, but the pie is cut such that producers get a tiny little sliver of it and consumers get like the rest of the pie. So that's not equitable. Okay, so the picture you should think about here is efficiency has to do with how big or small the overall pie is. So this is kind of efficiency. So actually I'll write little here. So this has to do with how big total surplus is. Equity has to do with whether or not the pie is fairly split between consumer surplus and producer surplus, or maybe one side of the market isn't getting as much well-being or surplus as the other side. So equity has to do with whether the pie looks more like this or more like something like that. Okay, let's think about how these kind of interventions in the market changed efficiency and equity. Okay, if we let the market be and we don't touch it and the market reaches the equilibrium price, well, efficiency is maximized. That's because the triangle here is bigger than all the other cases. The way I've drawn it here, which this is not always the case, but the way I've drawn it here, things are pretty equitable too, because the consumer surplus, the top triangle, is about the same size as the bottom triangle, which is producer surplus. Okay, if the price is increased above the equilibrium, so say the government comes in and they do something, and as we'll talk about in a minute, maybe they impose a tax. Well, what happens in this particular scenario? Well, efficiency falls, so the whole pie shrunk a little bit because the black shaded region is smaller than originally it was. And now we kind of have an equity dynamic where the consumer surplus is kind of like shrunk up here, and the producer surplus is expanded. So this would be a situation where we're moving towards something that looks kind of like consumers are getting a tiny slice, producers are getting a big slice. So we've compromised. Okay, here's one of the joys of online teaching. I got done recording the entire lesson. I was going to make it in advance. I was going to be prepared for class, and at some point the thing stopped recording. So once I realized it, one, I got sad, and then two, I tried to like redraw where I left off. So when the video cut out, what we were talking about is if you have a market and the price is raised above the equilibrium, what happens? It generates a distortion in the market such that the whole pie size contracts. We have a little amount of welfare that's no longer realized by anyone. And moreover, in this setup, the consumer surplus shrinks, the producer surplus gets bigger. And so now we have an equity issue also, because the pie slice that goes towards consumers gets itty bitty, and the pie slice that goes to producers gets huge. Okay, over in this setup, we also have a loss of efficiency because this whole shaded area here is smaller than the whole shaded area originally. And we also have an equity issue here, but the equity issue is reversed. So in this setup, consumers do relatively better than producers. So this would be a situation where the equity ends up being such a producer surplus is itty bitty, consumer surplus is quite big. Okay, one thing that I'm just going to highlight, if you like politics, or if you don't and you vote, this is still important to know. A big difference between, in the American political system, Democrats and Republicans, is how they think about efficiency versus equity. Okay, so I think this was the thing that was already in your notes that was there before the video cut out. So efficiency has to do with like how big the total pie is. So in other words, you want to like maximize total surplus. Equity has to do with not how big the pie is, but again, like how evenly the slices are cut. So if you have a pie that's sliced down the middle, so consumers get half of it, producers get half of it, and consumer-producer surplus are even, then that is a different story in terms of equity compared to if consumers get most of the pie, producers get a little bit. Okay, the reason I'm pointing this out is because Republicans typically prioritize efficiency over equity. So a Republican would say, we would prefer to have an economy that's as big as possible, regardless of equity, whereas a Democrat would say, we would prefer to have an equitable economy where producers and consumers are getting kind of fair cuts over having an efficient economy. So the reason this is important is because there's often situations where these two things are at odds. So in other words, you have to trade some efficiency to get more equity. So I'm going to draw you a picture to give you an example of that kind of scenario. And the reason I'm pointing out this scenario is because, so I'll say this, both Republicans and Democrats both like efficiency, they both like equity. So if there's some way, the way I had on the board, where if you operate a market in that way, you get efficiency and equity, then all policymakers are going to be on board with that. But what's often the case is that, again, there's this trade-off. So more equity is going to come at the expense of less efficiency. And then that's where the Democrats and Republicans are going to butt heads a little bit, because Republicans would say, we need to go for the efficiency. Democrats would say, we need to go for the equity. Okay, so let me write this a little bit, and then I'm going to draw a graph. So sometimes you have to give up efficiency to get equity. Okay, so let me show you an example of this. So we're going to draw a graph here. We're going to draw two side-by-side graphs. And when you draw this, the important thing is that you make the supply curve really steep, and then make the demand curve kind of shallow, and then just draw it again, because we're going to just compare these two different things. So steep supply curve, shallow demand curve. Okay, if we let the market be, so if we didn't touch it, then what would happen is the market would end up at the equilibrium. This would be the price. And if that was the price, then this top triangle would go to consumers. This would be consumer surplus. The bottom triangle would go to producers. That would be producer surplus. Note, there's not much equity here. So producers are doing a lot better than consumers. But we've got this whole big triangle. So efficiency, okay. Okay, now let's suppose the government they had the option of somehow coming into this market and distorting the price such that it's below the equilibrium. So maybe they come in and they say, we're going to lower the price below the equilibrium. Okay, if this is the price, then at this price, this is the number of units that would be supplied. So the market's going to kind of be stunted right here in terms of size. So let's think about how this would affect things. So for the suppliers, or for the producers, let's start with them. The producer surplus is the area underneath the price above the supply. So this area would be producer surplus. What about consumer surplus? Well, the market has now been stunted right here. Like, this is the number of units we're exchanging. Consumer surplus is the area that's underneath the demand curve above the price, but we have to stunt the growth of the market right here. So this area right here, again, is going to be consumer surplus. Okay, let's just think about the trade-off now, from going from this type of government policy where we don't touch the market to this type of government policy where we touch the market. Okay, let's do a head-to-head comparison. If we're looking at efficiency and equity in both markets, one of them wins on one front and the other one wins on the other front. So first of all, efficiency. Which type of government policy is more efficient? This type of government policy where you don't touch the market is going to be more efficient because the total surplus is bigger. So total surplus, again, is the overall economic well-being of everybody, which is represented by the size of the whole, in this case, triangle, where you have consumer surplus plus producer surplus. This is bigger than total surplus over here, which is this weird area, because we've lost this. This is the deadweight loss in the market. So this market has more efficiency. Like, it's bigger, it's stronger. Okay, what about equity? This market wins in equity because over here we have like a really big pie, but there's a tiny little slice that goes to consumers, a big slice that goes to producers. But over here, even though the pie is like kind of dinky because we have some dead weight loss, if you shrunk together these two areas and kind of turned it into a circle, then about half the circle would go towards consumer surplus, half would go towards producer surplus. Okay, so again, this is where whether you're on the left or you're on the right, you're going to differ in terms of which approach you think would be better for the government to pursue. A Republican would say, we prioritize efficiency over equity, hence we need to let the market be, we don't touch it, and that will give us the strongest economy possible. That is true. Okay, a Democrat would say, we prioritize equity, so we want to make the market as fair for consumers as producers. The way we would do that in this particular setup is to lower the price. That is true. If they lowered the price, it would result in more equity. So this is where, like, there's not a clear-cut one of these two ways would be better. It just depends on which one you prefer. If you prefer efficiency versus if you prefer equity the most. Okay, so one important term that gets thrown out a lot that you should just be aware of, because you'll probably hear it in policy debates, is, it's wrote on my wall, is laissez-faire. So it's Laissez-Faire. Okay, so a lot of times you'll hear people say, I am in favor of laissez-faire economics. That basically means that they're in favor of prioritizing efficiency over equity. So the literal translation is let the people do as they will. So let the people do as they will. Okay, how does that translate back to this? If you let people, which are players in markets, do as they will, then that means you just let them do what they're going to do, and the market just shakes out, and you end up at the equilibrium. So if you let people do as they will, you're going to end up in the equilibrium price. If you end up at the equilibrium price, you're going to maximize total surplus. Maybe you'll have equity, maybe you won't, but you're going to definitely have total surplus that's large. So if you hear anybody say that they're in favor of laissez-faire economics, basically they're a libertarian, and so that just means they want to kind of let the market forces go so that you reach the equilibrium and you maximize total surplus. So here's kind of dumbed down translation. Laissez-faire economics or ideology basically means don't mess with the market so that it reaches the equilibrium and total surplus is maximized. Okay, so that's kind of your poli-sci word for the day. What I'm going to do now, this is the end of Chapter 7. Chapter 8 is just an application of Chapter 7. So what I'm going to do is I'm going to just hit the highlights of it just so that you can kind of get a taste for it. And then trust that you go back and read it on your own because I don't want to take your whole afternoon by explaining it in depth. So we're going to quickly go through Chapter 8, which is really cool because it talks about how taxation, which we already learned about, relates to consumer surplus, producer surplus, total surplus, and as a result, both efficiency and equity. So here's like super bare bones lesson on Chapter 8. So the title of the chapter is Application, the Cost of Taxation. Okay, what we're going to do here is we're going to consider how taxes affect consumer surplus, producer surplus, and total surplus. So consider how taxes affect consumer surplus, producer surplus, total surplus. And if you know how total surplus is affected, you know how efficiency is affected. If you know how producer surplus and consumer surplus are affected, you can make statements about equity. So for the sake of time, I'm just going to give you one kind of case. This extrapolates to other cases. So basically, I'm giving you kind of a demonstration of the results using one story. But if you read the textbook, you'll kind of get all the stories that reach the same conclusion. So what we're going to do is we're going to, so the case we're going to consider is suppose the government levies a tax on producers. Okay, what we're going to do is we're going to take what we've already learned about taxation. We're going to repeat those graphs of what the market would look like after a tax is levied on producers. And then we're basically going to trace out where is the consumer surplus on that graph, where's producer surplus, where's total surplus. So to do this, we're going to have, I'm going to do a pre-tax graph and then a post-tax graph. And then we can kind of just make some comparisons. So pre-tax, we're going to keep drawing the same thing. So we have a baseline. So we have a supply curve. We have a demand curve. If there's no tax in the market, the government doesn't do anything, we've reached the equilibrium. We have consumer surplus that's up on this top triangle. We have producer surplus that's down on this bottom triangle. And then you add them up together, the whole thing in aggregate is total surplus. Okay, what about the picture if a tax was levied on producers? So you would have the original supply, the original demand, and again, recall if the government slaps a tax on producers, then what producers do is they basically say, I'm going to take my sticker price, I'm just going to up it by the amount of the tax, because that way I'll get the original amount that I was getting, and then I can just take the extra tax amount that I'm collecting from people and just send it off to DC. So graphically, this causes the supply curve to just move up, literally move up by exactly the amount of the tax. Okay, so this will be the supply under taxes. Okay, what this is going to do to the market is we're going to move from this crosshair to this crosshair. So this is the new price under taxes, so BET. And now let's just start shading in areas. So the easiest thing to kind of detect on this is the consumer surplus. So consumer surplus is the area that's above the price, below the demand. So this triangle here is going to be consumer surplus. Okay, now let's think about producer surplus, and this is where things get a little bit tricky. So the producer, technically they're making a higher price. So the original equilibrium price is lower than the new price under the tax. But the catch is that even though they're bringing in a higher amount at the register, for each unit that they sell, they have to subtract out the amount of the tax because they have to take some of that money and send it to the government. So for the seller, the effective price that they get is going to be the price they bring in at the register minus the tax. So this is the price they bring in at the register. Let's go down T units. And note, if you go down T units, you're going to hit the supply curve because we took this supply curve and we just moved it up by T units. So if we take this price and go down by T units, you're going to hit supply. And now this is kind of like the real price producers get. Okay, so for producers now, they're really getting this price. And producer surplus is the area underneath the price that they're really getting above the supply. And so this is going to be producer surplus. So far we have these two little chomping triangles that are accounted for. Okay, here's another thing I want you to think about. So some of the money in this market got sent to the government, right? So government revenue is government tax revenue, in very basic terms, is just equal to the number of units that are sold on the market times the amount of the tax. So for instance, if the tax is like $1 per unit and there's 100 units that are sold, then total tax revenue is $100. Okay, here is the quantity of units that are exchanged in the market. Here is the tax. So think about just the area of this rectangle here. This rectangle has a base that is equal to Q. This rectangle has a height that is equal to T. So if you take a base times a height, you're taking Q times T, you're getting the total government tax revenue. So the area of this rectangle is the government tax revenue. And so we need to incorporate that in the total surplus, because now there's not just two players in the market, there's not just producers and consumers, now there's three. There's the consumers, there's the government who gets some money, and there's the producers. Okay, so what that means is that the total surplus is going to be equal to the consumer surplus, so that top little triangle, plus the producer surplus, which is this bottom triangle, plus the government tax revenue, which is the middle rectangle, and that whole thing is the total surplus. Okay, so let me kind of do a head-to-head comparison between a world with no taxes and a world with taxes. So in a world with no taxes, in a world with no taxes, consumers get this, producers get this. Total tax revenue is this whole triangle. In a world with taxes, consumers get this, government gets this, producers get this. So that means total surplus is the area of this whole weird shape here. So a tax is first of all going to cause total surplus to fall. And the way we see that is because this triangle is bigger than the area of this shape. We've got some dead weight loss here. Nobody got that. Furthermore, consumer surplus fell. So consumer surplus used to be this huge triangle. Now it's this dinky triangle. On top of that, producer surplus fell. Because producer surplus used to be this whole big triangle down at the bottom, now it's this dinky little triangle down at the bottom. The only thing that increases is the government tax revenue. So before, clearly there's no government tax revenue because there's no tax. You impose the tax, now some money gets taken out of the marketplace participants' pockets and sent to DC. The amount of money that gets sent to DC is equal to the area of that blue rectangle. And so the government tax revenue does go up, but in total, the total surplus in the market has fallen. Okay, so main takeaways here is anytime you impose a tax, that is going to introduce a distortion in the market such that we get nudged off the equilibrium price. Anytime you get nudged off the equilibrium price, there's definitely going to be an efficiency loss. So total surplus is definitely going to fall. What's also going to be the case is we can't make blanketed statements about equity because it depends on whether these two triangles are more similarly sized than these two triangles. But what we can say is that overall consumer surplus is definitely going to shrink a little bit. Producer surplus is going to shrink a little bit. So depending on which one shrinks more, that's going to kind of tell us about equity. And the last thing I'll throw out, and then I'll leave this for you to just kind of read extra on if you want to. So I gave you the case of the government levying the tax on producers. Exactly the same results materialize if the government instead slaps the tax on the demanders. So if the government slapped the tax on the demanders, you would take the demand curve, you would move it down by the amount of the tax, but the areas of these shapes actually would be exactly identical to what I've drawn here. So if you're interested in that, read up on it. I'm not going to push you super high on this in the exam, but I just want you to be exposed to it so you can kind of understand what's going on if you're listening to the news or debates and they bring any of this up. So if you have questions about this, let me know, and then after 10 minutes, we'll meet back for the exercise. Okay, for the exercise today, I know we're running short on time, so I'm going to spoon feed you a little bit, so don't run away to the Blackboard submission site because I'm going to kind of give you lots of helpful hints. I'll make this quicker. So the question is, suppose you have the following supply and demand. Both of these equations are in slope-intercept form. Question number 1 is, at what price is total surplus maximized? Okay, the big hint here is that total surplus is always maximized when the price is the equilibrium price. Where is the equilibrium price? Equilibrium price is the price that emerges when supply and demand intersect or they equal each other. So to answer question 1, what you need to do is you need to take demand and set it equal to supply. So you would take this equal to this. You would solve for the Q, and then you would take your value of Q and plug it into either one of these two equations, and a P will spit out. That's the equilibrium price, and that's going to be your answer to number 1. Okay, question number 2 is at the equilibrium price. So you're going to take that number that you have from question 1 and answer with that equilibrium price, what is consumer surplus, and then after that, what is producer surplus, and then after that, what is total surplus. Okay, here is what you're going to need to do to solve for that. And here's where I'm going to help you substantially, hopefully. It's going to be easiest to calculate the areas of these triangles if you just draw the curves. So let's draw demand together. So the demand curve has an intercept at 400. It has a slope of negative 100, so you're going to go down 100 over 1, down 100 over 1. That's going to hit the x-intercept at 4. So the demand curve is going to have a price intercept at 400, a quantity intercept at 4. Okay, that's a big hint. Okay, supply has a price intercept at 100, and then it has a slope of positive 50. So you're going to go up 50 over 1, up 50 over 1, up 50 over 1. So that's going to give you a supply. Okay, your answer to number 1 is going to give you a particular price level, and then you also implicitly solve for an equilibrium quantity level. Okay, so to calculate number 2, what you need to do is you need to calculate the area of this top little triangle. That top little triangle has an area of 1/2 base times height. The base is the quantity. The height is 400 minus the equilibrium price. Multiply those two things, divide by 2, you got question 2 done. Question 3 is, what is producer surplus? Producer surplus is the area of the tiny little triangle at the bottom. The area of the tiny triangle at the bottom is 1/2 base times height. Base is Q, height is price minus 100. And then question 4 is, what is total surplus? There's 2 ways of doing that. If you do them both ways, you should get the same answer. Way number 1 is add these 2 things together. Way number 2 is calculate the area of this entire triangle. This entire triangle has a base of Q, has a height of 400 minus 100. Okay, so this is what you need to turn in. 2 things, actually. So on the screen, when it switches over to the text, there's going to be like a little extra practice blurb. You don't need to turn that in, but if you want extra practice on doing this when a tax is imposed, I've given you a little question, and then Blackboard, when you submit the answers to these, it'll give you, when you submit your responses to these, it'll give you correct answer for these, and it'll also give you correct answer for the little tax extra thing. So just use that for practice. You don't need to turn it in. And then the last thing is your reading assignment for next class. So next class, we're going to move on to chapter 9. So read chapter 9 on your own. Chapter 9 is another little like application chapter. So just like we looked at the application of taxes, we're going to look at the application of all of this stuff to international trade. So good luck on this. Again, if this is confusing, definitely reach out. Don't feel shy about asking questions, and I will see you next class.